Hi guys, welcome to Learn Electronics Repair. I have an amplifier to repair here. This is quite an old one. I can show you. Yamaha Professional Series PC2002M. I believe this is about 30 years old, maybe older. And the fault with this is that the protection on channel A and channel B both light up. So it's going into protection mode on both channels. Because of that, I'm actually not going to power this up straight away. I'm actually going to have a look inside it to see if we can see anything obvious as to why that's happening. Let's see what's inside this. Well, quite a lot of stuff. Yeah, quite a lot of stuff inside this. That's the best way to put it. So we clearly have the two amplifier modules. This is the transformer, toroidal transformer, very large. This is the preamp section, if you like. And it looks like the smoothing capacitors are here. Is bridge rectifier, I can see. The two more things there with like studs in them. These feel like they're capacitors. Yeah, I'm just looking down there. They are, by the way, sorry, they are capacitors down there. Can you just see the size of those things? Okay. So this is one terminal, this is the other terminal. Positive, negative, it looks like. So that's basically what we have. These things can be quite difficult to work on to get these modules out. Looks like this one is bolted from the side. Okay, can you see? Yeah, sort of down here and here. Bolts are the same at the front. So these probably just come off sideways on this one. But even before I start to dismantle this, I think at least we can check if there's any shorts on the main voltage rails by checking across these capacitors. If we have short circuit output devices, it will probably show up here. Let's see. So this is probably ground or 0 volts, plus and minus. What have we got? Well, there's no short on the positive rail. And there's no short on the negative rail either, which suggests the main output devices are okay. That's the transistors, if you like. So those sort of look all right. So I don't think we have a short. We could have a blown fuse somewhere, of course, but it doesn't seem so likely. In that case, then I think the next thing I will do with this is to plug it in and see what happens. We'll put the light bulb on as a current limiter and then let's see what it does. Okay, we have the current limiter. You can see it in the inset just below me. Okay, so what you would expect this to do is come on bright and then go dim or off. Actually, let's see what it does. Well, it doesn't do anything. I'm not sure the on-off switch is working on this. I don't think the on-off switch was switched on, actually. Let's try again. Bright, and then dim. It stays on, so obviously there's power in here. Let's have a quick look at the main voltage rails with that on. But it's going out now, that's what you would kind of expect it to do. So we're on volts range. Let's have a look what we have. Well, we have 56 and 57 volts. Positive. 58 volts negative. It is doing what the owner said it would do. Both protection lights are on the front. Okay. So that's interesting. I don't see any problem with switching this on without the light bulb in now. If the worst thing could happen is probably a fuse will blow somewhere. Let's try it. So we'll switch that directly to mains. We'll switch this back on again. Let's see what it actually does. Well, it's powered up. And the protection lights are on. I'll just check the supply voltages again. They've probably gone up a little bit, you'd think, because it isn't limiting the current anymore. Yeah, 87 volts minus 87 volts. That looks okay. So why is the protection light on? Well, another thing I've noticed, I just tried this. So it's been switched off for about a minute. And we still have 68 volts here, and we still have 67 volts here. So they are discharging slowly. So nothing is drawing a lot of current from the capacitors. That's another interesting thing. I think I will actually see if I can find a schematic for this. I found a service manual with a schematic on this site, Electrotanya. This is a very good site for finding schematics. I can recommend this one. I've never had a problem with any downloads from here, viruses and such like. When I download a PDF, I get the PDF. You can download free of charge, 5 files per day. They also have a forum on here. This is not an English language site. I think it's Czech language. I could be wrong, but it's something similar to that. I hope I haven't offended somebody, by the way, with my lack of knowledge of the language of this site. And here is the service manual that we have. So this gives us some information on how to dismantle the amplifier. DC board, DB board, it tells you how this comes apart pretty much. Front panel removal, etc. So that could be useful. It has some voltage adjustments, some information here. That may be helpful. Shows us here where they are. Block diagram. We have the layouts for the various circuit boards. And we have the schematic. This is the main amplifier, one channel anyway. It shows us so. Typical NPN, PNP transistor, channel output. Protection will monitor from here somewhere. What normally happens with the protection is it's monitoring to see if the voltage supply rails are present, and it's also monitoring to see if there is any DC offset on the output before it closes the relay to connect the speaker. Any DC output here will damage or destroy the speaker and possibly the amplifier as well. So before we start tracing this through, let's check if we have any DC offset on the output of both channels. And we have protection on both channels. So you would think whatever is wrong with this is affecting both, by the way. That maybe makes me think that one of two things has happened. We have the same fault on both amplifier modules, or something common to both of them, a power rail or something, is where the problem is. Let's look for the DC offsets first. To do this is very simple. We switch the amplifier on and we check the voltage across the output, the speaker terminals. So that is 0 volts exactly, actually. That surprises me a little bit. But in second thoughts, it doesn't surprise me a little bit. It's exactly what I would expect because the relays are not operating. So that means the speaker terminals are not connecting. Therefore, that is not telling me if there's a DC offset. To find this, we need to get onto the circuitry where the relays are. I suspect they're on the main amplifier modules, and if they are, we probably have to drop these boards down to the side. Actually, just looking down, I think I can see the relays. One of them is basically down there, black thing, and the other one down there. So we will have to see if we can get these boards into a position that's accessible to work on them. While they are connected, this may be difficult with the construction of this amplifier, but guys, there's only one way to find that out. At the moment, there'll be quite a lot of voltage in the main capacitors because there doesn't appear to be any load as such on this, or not much of a load. So we can just check. Yeah, still 44 volts, 44 volts. I could discharge the capacitors, but I think I'll just leave them a little bit, let that voltage just dissipate away, and then we can take a look. I think the schematic for this will shed a bit of light on what's going on. I suspect that the problem is in the power supply, and that's because we have to protect on both channels. If it's a fault on the amplifier channel, we effectively have faults on both of them. Whereas the power supply is common to both, and that's why I'm thinking that's what we should check first. Also, as I will show you now, the schematic sheds some light on why I'm seeing 87 volts on each of these, plus and minus. And I did say, well, they're both the same, so I think that is correct. Here we have a block diagram. This is quite handy, I think. We can see we have the input to channel A, channel B. It's just showing channel B is the same as channel A, and it explains channel A a bit more. We have the signal coming in. You can see here it comes through. This is the clip detection. The signal then comes through onto the base of the NPN and PNP transistors. This bias circuit effectively sets both of the bases so they're almost all just about turned on, actually probably just about are on, and then the waveform drives the NPN and PNP further on the positive half cycle, the negative half cycle. You can see a pre-driver, a driver, output stage of 4 transistors in parallel, and this is the output. Here is a relay, and we have this DC detecting or relay drive and the signal PR, protect. So it does look that the protect circuit basically detects if there is a DC offset. Here, this is the connection to the speaker. If there's no DC offset, as there shouldn't be any, then it turns the relay on and connects the speaker. The protect signal then comes down here and lights the LED. So we can find this on the schematic. We also have the DC power supply we can see here. So we have plus and minus 80 regulated, plus and minus 15 regulated, and 12 plus regulated. We also have plus B and minus B, plus BA and minus BA. Those are unregulated. So these are the supplies coming directly from the bridge rectifier and the large smoothing capacitors. And I think B plus and minus is the one that I was actually measuring at 87. I'm not quite sure what BA minus BA are, but I suspect they are the rails that then generate the plus and minus 15. So these might be plus and minus 18 or 20 or something like that. That's a guess, okay? Let's have a quick look, see if we can determine a bit further. Here is a little bit of also useful information. You see they are telling us the wire colours, the abbreviations, black, brown, red, orange, and so on. Violet, grey, white, sky blue, pink, grass green. I assume that's a paler green than green, and sky blue, I guess, is a paler blue than blue. And that will help us because we can see all the wires here. So we can see where these various voltages are. This is one of the amplifier channels. We can see the 4 output transistors in parallel that we can see on the block diagram. And we can see the relay contacts that connect the speaker. And this relay is switched from here. So this is the relay coil. You can see that is switched by this IC. This is the output. So this is what switches the relay on. The other end of the relay coil, yeah, plus 12. That makes sense, 12 volt supply. So basically, this chip, IC301, will effectively connect this end of the relay to ground. I think this is ground. It says here from PDA minus E12. I think this is ground. I'll explain why. Apart from having an E symbol, which sounds like Earth, the reason is this. If you look at how this circuit is working, this is an operational amplifier. And it will be comparing 2 inputs. So we have this input, which I think is ground, and we have this input, which comes from this resistor divider. So you can see about 120k, roughly 30k. So this resistor is 4 times the value of this one, okay, 30, 60, 90, 120, roughly. So whatever voltage is on here, about a quarter of it will appear here, and that's what goes to this chip, about a quarter of the voltage that's there, okay? There's a couple of capacitors that smooth the voltage to stop any noise or spikes, switching the relay by the looks of it. And let's see where this voltage comes from. It comes from here. And look where it goes. It goes to this side of the relay. So this is monitoring the voltage between the two sets of output transistors. This is what I was describing when I said you could have a fault with DC offset here. And if there is a DC offset of voltage here, you don't want to connect the speaker because of damage to the speaker or the amplifier. And that's exactly what this is doing. It's monitoring the voltage there. And as long as it is basically 0 or very close to 0, it turns the relay on. If not, it turns the relay off. Okay. There's a transistor here, and I think you can see that when this relay turns on, the voltage here goes to 0, so this one turns off. The emitter is 2 diode junctions above ground. I think this is ground. So the emitter will be at about 1.2 volts. So when this turns on, the voltage here goes down, this turns off. So the voltage here goes up, yellow. Let's see where that goes up. We'll go to the LED, I'm sure. Well, I'm looking now. I think these are protection LEDs, not quite the normal symbol for an LED, but they look like they could be. We have protection channel A, protection channel B, but we also have protection CHB, which seem to be different LEDs. It may be that these are kind of options and our board has one or the other. It certainly looks like we have a 12 volt supply here through some resistors, and then these LEDs can be turned on via the signal on the other end. Now this says white and violet, which don't match the yellow. I think the signal goes somewhere else first. The reason I think the signal goes somewhere else first is because we just saw that the transistor turns off when the relay turns on and puts a high or 12 volt on the collector, so it can't directly be driving these LEDs unless this end literally is ground and this is where the power's coming from, but this actually says not. So I'm not too worried just about that at the moment. I am quite happy I can see basically how this operates. I'm not too worried about how it turns the LED on. I'm more interested about how it turns the relay on. If we get this working correctly, I'm sure the LEDs will also work correctly. The other thing I'm just not totally sure of about this is this thing I called an op amp. Because it makes sense if the input here is higher than that one, basically it will turn the relay off. But it also has to do that if the input here is lower than ground, if we have a fault on the negative half of the amplifier. These transistors, then the offset voltage here, the DC offset, could be negative. So I'm not totally sure what this chip actually is, but I'm confident it would have to turn the relay off if there's either a positive or a negative offset here above a certain amount. Another thing that makes me think that is the case, if you look at these strange symbols for capacitors, these are not the ones you normally see, but I think these are non-polarized capacitors, 10 microfarad, 25 volt. And the reason for that, if we just look elsewhere on here, we can see your electrolytics with the plus signs on polarized. So that's another strong indicator, in fact proves it to me, that this could be positive or negative with respect to ground, and this chip somehow or other switches this relay off if there's a positive or a negative offset. Not quite a normal op amp then. Now what I think is wrong with this is possibly a problem with the power supply. You can see here we have a plus 12 volt supply to this chip. We also have plus and minus 15 volts, plus and minus 80 volt supplies on this. If one of the regulated power supplies isn't working, it may explain why we have the problem. And this is the power supply section. We can see we have AC coming in here, large bridge rectifier, red, white, and these go to the 22,000 microfarad 100 volt capacitors. I'm certain this is where I was reading the plus and minus 87. It makes sense that the main amplifier power to the output transistors does not come through a regulator because of the current. So I'm confident that's where I was seeing those voltages. We have another supply, plus minus B rectifier. This has 16 volt capacitors on, so I'm fairly sure this is what is generating via the regulator, the plus and minus 15, and probably the plus 12 as well. No, actually I'm wrong. This is the, it says plus minus 12 volt regulated supply, but it's not. Look, we have one side of the bridge rectifier, the negative side, going to the black wires. This is ground, this heavy black line, this is ground, and the other end of the bridge rectifier comes through a regulator here, giving 12 volts plus. So this is actually a plus 12 volt supply. We then have a plus and minus 15 volt supply here, two regulators. Yeah, look, 2315 plus 2315. So that supply is not the same as this one. I'm not quite sure what this one's doing at the moment. Red, pink, blue, sky blue. No, this definitely has its own winding, so that's that one. And we have this, the plus and minus 80 volt regulated supply from another winding. And again, it has its own voltage regulator circuit. It's coming through this transistor, which is basically regulating the output and regulating the negative output. The other useful thing we can see here is the colors of the wires. So we can see which colored wires have the output from the regulator board. And that means we can go and check these voltages. So I'll just make a note of the colors from here, then we'll look at our amplifier. This is what we should have. This and this board together are the DC power boards, basically. So starting with the regulated supplies, these are all regulated supplies. We have the plus and minus 80, two red and two blue. I'm pretty sure all the regulated outputs come from this one. We have two red and two blue. So that would seem to be those ones. Then we have three pink and three sky blue. Oh yeah, look, three pink, three sky blue. These are the plus and minus 15. We have two grass green. This is NFF supply. I'm not quite sure where that is actually. Okay, I'll come back to that one. We have three brown, which is the 12 volt, which must be those three. We have one yellow, 12 volt L. That powers the lamps behind the meters. I can see that on the schematic. And then three black, or four black. 1, 2, 3, 4 black as ground. So that's really found all of those apart from the two grass green ones. I can see some pale green ones here. Can you see them? This must be the grass green. And these go down into this board. Yeah, those go to that connector. So that's where the grass green are. So that is N/FF. I'm not sure what that voltage is supposed to be. That's what it is. It didn't mark it on the schematic, the actual voltage. And then we have a few more. So we have two red and two blue, which is this B alpha and minus B alpha, plus and minus. We have a pink and a sky blue, which is B plus and minus. And we have red and white, which are B plus and minus. Now, the red B plus must be there because that's also the pink B plus. So that accounts for those and that one. Then the other one, yes, sky blue is going to be there. Sky blue coming to white. Yep. White, sky blue connecting together, B minus. So the only other ones we want to find are these 2 blue and 2 red, this B alpha thing. Yeah, I think I found them as well. There's 2 red there, and there are 2 blue here, just underneath the sky blue. So I think I've found all these voltages. Let's start then by seeing if they're there. These ones, we'll do the regulated ones first. I'm assuming if the regulated ones there, these are probably there. If all these are present, then I think we should have a look at these as well. We already know those ones, in fact. So this is the plus 87 volts, this is the minus 87 volts, and the same with this one, minus 87 volts, plus 87 volts. So we found those anyway. So it's only this B alpha plus and minus we might need to find. I'm pretty sure we know where they are though. Okay, let's get measuring. These are going to be quite awkward to get at because of where they are, and I'm not sure I can get these boards out while the thing's powered up. There's also a lot of high voltage here, plus and minus 90 almost, so you need to be a bit careful with this. What I am going to do is use this type of probe. So this is a flexible probe, so I should be able to get the probe into the connector. Yeah, far enough to make a measurement. That's the idea. We can test if that's actually working because we can connect our multimeter to ground, and if we see a resistance from here, then we know we're making a connection into the wires. Try the other ones. Yeah, we have it. Okay, so we get the connection there. Because of the high voltage here, I'm going to put a piece of cardboard over it. That isn't necessary. That's just, to me, a bit sensible, but this is down to what level of risk you want to work with. Yeah, what you're happy to risk. Personally, for what it's worth, I'm going to put a bit of cardboard over there. I also don't want my meter probe touching those high voltages and shorting something out. And to make it even a little bit more easy, I'm just going to connect a ground lead to here, and that is going to go to a large crocodile clip which is directly on the chassis. So I have a good ground connection. I only need to use one hand now. We can power this up, and then let's see if we can find our voltages. So the first ones are the red and blue, and these should be plus and minus 80. Okay, let's power this up. Let's see, so minus 80. Get in there if I can get a connection on it. I think I had it there. Yeah, minus 80 we have. Another connection here. Don't see anything. Unless I'm just not getting far enough in, it is awkward. How far did I go into this one? Yeah, I didn't go very far into that one. It looks like I don't have a plus 80. We'll double check that. Let's just have a quick look at the other one. So, pink and sky blue, these are the plus and minus 15. Not so much voltage here, I don't worry quite so much about it. Do we have it? Yeah, minus 15. Should we have a plus 15? I think we do. Just get a connection, yeah, plus 15 is there, minus 15 is there. I think 12 volt we can say is there because the lights are lighting up behind the meters. But we can find it. So brown is the 12 volt. In here. 12 volt is present. Grass green is this NFF. I'm not quite sure what that actually is. So I'm not going to worry about that at the moment. I'm going to go back to this plus 80. And it looks like I don't have it. Minus 80. I'm definitely not finding anything here. We can double check this, so we can switch off. Okay. There is some voltage in the capacitor still. Has the voltage here gone away on the regulator? Let's have a look. Looks like it. So I'm going to stick my probe in there and see if I have any resistance to ground. Am I making a connection? Yes, I definitely have a connection. Okay. Back to volts. Hold that there. Switch it on. And I have no plus 80. So I think we've found the cause of the problem. We just need now to find out the cause of the problem, if you get what I mean. These boards are going to have to come out. I've lifted the board out. You can see there it's lifted up. We can see the fuses. So this is the next one to test. If I could have seen the fuses before dismantling it, I would have just done this anyway, but I couldn't. I knew they were there. I just couldn't get to them easily. Let's see. Well, we have a bad fuse. We have two bad fuses. So the bad fuses are the two ones in the orange circuit coming in here. Let's have a quick look. That's actually this circuit. Those ones have blown. Okay. I will have to look to see why that caused no voltage on this one, if that is the case, after I've replaced those fuses. But let's just change them and then let's see what it does. In fact, actually, no, let's not just change them. Is there a short here somewhere? So, from the fuse to ground, no. I'm on continuity. No, I don't see a short to ground, and I don't see a short between them. So this will read short because of the transformer winding. There, okay. Looks like there you go to this bridge rectifier. I will check it, but I suspect this is actually okay because I'm not seeing any shorts. Let's have a quick look. Okay. So red on there to the positive. No. It's interesting. Oh, I do have. I just didn't have a good connection. Other AC, red wire to the positive. Probably the same problem, just not getting a good connection. Yeah, I'm reading it. And then the negative on the black to the, or the output, the negative output. Red here. Okay. It's okay. Short across the output of this, but remember the connectors are unplugged, so it won't really tell me much. No short there. Get a good connection. So that feeds which voltage? I just want to check for shorts on the output from this. This says it goes to blue and red, but it must go to this connector. It can't go to the other one. So let's just check which pins on here. Then we can find the wire that plugs on here and see if there's any shorts on them. So yeah, those N2 are the negative. I suspect the next two are the positive. No, the two after that. So this connector was this one. Yeah, now the colours match up. Blue, blue, sky blue, pink, red, red. So let's have a quick look for shorts on these outputs. So blue to ground. No. It's easier from this side actually. So from this side it's the easiest. Blue, resistance, ground. No, just a resistance. Red. Ground. No, just a resistance high. So there's no shorts that I can see. So let's change these two fuses. I've had a look. The fuses were T1.25. I actually don't have any. I have 1.6. I have 1. But I don't have 1.25. I thought I had everything in fuses. So what I'm going to do, I'm going to put a couple of 1 amp fuses in. These are lower rated, obviously. I want to see if the amplifier powers up. If it blows the fuses again, but they don't go bang, and to be quite honest, the other ones hadn't either. I'll show you. These are the ones I removed. Okay. So they haven't like blackened or blasted or anything. I think they've just gone. So given that, I'm happy just to try this with a 1 amp. If they go again but don't like blacken, then I'm fairly confident it just wants the right fuses put in, but I don't really want to put a higher rated fuse in, which means I shall have to get some. If it works, then I'll just get some of the correct rated fuses. Okay, so let's try it. Okay, so let's see what this does now. I'll just plug in, I'll switch it on, and let's see what happens. Well, we still have the protection lights on. So it's the same as it was before, protection lights are on. I'll just let these capacitors discharge again. I want to check, see if these fuses have blown again. Let's see. I mean, they look intact, I will say. Yeah, fuses are okay. So check all the others again. They look okay. Let's have a look at this B plus power supply. That's on the board, that one. I've had a look at this regulator board. This is the output transistor for the plus 80 volts regulated. These various transistors, this area of the circuit is all part of that. The power comes in from the bridge rectifier and the large capacitor here, and then this powers the circuit. So I can't find anything actually wrong with this. I haven't taken any components out, but all the semiconductor junctions test okay, the diodes test okay, it looks okay. What I have tested is that we have a connection from the bridge rectifier to here, which we do have, so power must be getting into this. So I'm thinking now I may have to power this up by connecting this back to the amplifier. I think if I stand the amplifier up vertically, I can probably connect this and be able to probe around on it. So I'll get the amplifier back on the bench and let's see if we can get it into a workable position. Here's the amplifier. I've just thought actually that I should check something, because if everything looks okay on that regulator, we don't have any output on the plus 80 regulated. Maybe there's too much load, like a short or something. Let's just take a look. So this is the negative 80, minus 80. And that reads about 6 meg to ground, very high. And this is the plus 80. And that reads low, like about 80 ohms. That's like 1 amp at 80 volts. It's not something stupid because of the polarity, is it? Because this is a minus supply related to ground, and this is a plus supply. Let's have a look. So, yeah, that still reads 59k now. So, okay, that polarity reads a lower resistance. That's the polarity that would normally be on that wire. And the other one again. Well, that reads high now. So, there's something a little bit strange here. When we have the positive on here, what's happened? It's changed. Guys, you saw that, yeah? You saw it. 79 ohms. There's 2 red wires. Hold on. 79 ohms on that one. very high on that one. And the blue, we'll go the opposite polarity to be sure. High. High. So it looks like one of these amplifiers may be the problem. Is this the connection? I'm not sure. It's red and blue. I'm just thinking. Is that the red one of them? Yeah, that's one of the reds. And I guess the other red is here. Okay. Yeah, it is. And then, not that it matters, but this will be the blue. Okay. That should be the other blue. So it looks like there's some sort of problem on this amplifier. This from the 80 volts regulated to ground. Yeah, that's got to be investigated. So I'll put this part back together. I don't think the problem is there. From what we've tested, it's fairly certain the problem isn't here. The problem appears to be on this one. I could double check that by disconnecting that and seeing if we have the plus 80. Yeah, could try that. Okay, I have this one disconnected. Let's see if the protection goes off on the other amplifier, yeah, the other side. I'll try and put this where you can see it actually. I've turned the amplifier the other way around. I've disconnected this. The reason I've turned it round is so you can see the protect lights, which are over here. So let's see if we now only have protect on one channel. Well, in actual fact, the protection went off on both channels, okay? The protection went off. We've got somewhere, guys. We definitely know where the problem is now. On this one, we have a schematic, so we should be able to find it. This is not a short. It's like a short through a resistor, maybe. But I don't want this video to get too long. I know how some of you guys are with the attention, or put another way, if I go on for too long, it gets boring, yeah? So part 2 coming up on this one. Maybe tomorrow, if not tomorrow, over the next couple of days. Well, it's the weekend, but soon, yeah? And we'll figure out what's actually wrong with this amplifier module. I hope you guys followed what I was doing with the schematic there. I was trying to show you how I go about using a schematic in repair, and the other things I was kind of figuring out, like it was a power supply rail, and I was kind of right. I just wasn't right about the cause of the missing power supply rail. But that itself didn't take too long. Once I got the board out and realised there was nothing wrong with it, it must be something else. So I hope you enjoyed it. Please, comments below. This will be on a definite part 2 soon, and I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.